simple distillation. We are looking at the separation technique called simple distillation, where the diagram on the screen shows the setup of apparatus used in simple distillation. Let's start by discussing what type of mixture is simple distillation used to separate. Simple distillation can be used to obtain the solvent from a mixture of a solute and solvent, which is known as a solution. What are some of the examples of mixtures which can be separated by simple distillation? This includes copper 2 sulfate and water, or seawater, or even tap water. From each of these three mixtures, we will obtain the same solvent, which is distilled water. Let's take a look at the apparatus which is used in this method of simple distillation. We will need a distillation flask. There's a rubber bung at the top of the distillation flask into which the thermometer is fitted. There is a condenser attached to the distillation flask, and we will also need apparatus with which to heat our mixture, which is to be poured into the distillation flask. So this means that we are going to need a tripod stand, wire gauze, and this label here, which shows heat, represents that we are using a Bunsen burner. Below the condenser, you're going to see a conical flask. Right, the conical flask may need to be supported on a tripod stand depending on the arrangement of the apparatus. Let us explain what happens during simple distillation such that we would obtain the solvent. We're going to start with the mixture that we're using, which is copper 2 sulfate and water. Copper 2 sulfate and water would be placed into this round bottom flask called a distillation flask, to which we would add a substance called anti-bumping granules. I'll explain what these are used for. On placing the solution into the distillation flask, attaching the necessary pieces of apparatus, we would then begin to heat the solution. On heating the solution, eventually the solution will begin to boil. So in terms of the processes happening in our experiment, one would be boiling. Now consider the setup of the apparatus, which is a lot of glass. The purpose of the anti-bumping granules is to help to smoothen the boiling which will occur. Remember that boiling is accompanied by, or it is signified by, vigorous bubbling. So the anti-bumping granules are meant to smoothen that boiling, right, to avoid any accidents of glass breaking, etc. So let's go back to what's happening in our experiment. The copper 2 sulfate solution will begin to boil. Water, which is present in the mixture, will boil into water vapor. That water vapor will travel up the distillation flask where it will pass the bulb of the thermometer and enter into the condenser. What do we think happens in the condenser? Obviously, yes, the answer is condensation. So the water vapor will travel down the condenser where it will cool into distilled water. The distilled water will drip out of the condenser into the conical flask or receiver, and the liquid or solvent which is obtained is referred to as a distillate. So boiling will occur in the distillation flask, condensation will occur in the condenser, and we will collect our distilled water as the distillate in the receiver. Let us also try to examine our apparatus and explain why it is set up the way that it is. Two questions I would ask are, why is the thermometer placed at the top of the distillation flask? Why do we even need it? And two, why does cold water enter at the end of the condenser and exit at the top? Let's start with that first question of what is the function of the thermometer? As the water vapor travels up the distillation flask, before it enters the condenser, it must pass the bulb of the thermometer. So the thermometer is meant to measure the temperature of the water vapor, and in doing so, it measures the boiling point of the liquid. Once the boiling point of the liquid is constant, this means that the real function of the thermometer, or the answer I'm getting to, is that the thermometer is meant to ensure that the distillate obtained is pure. So this is the function of the thermometer, to ensure that the distillate is pure. Now, why would we want a pure distillate? Why wouldn't we want any impurities in there? Now, the purpose of these separation techniques is to obtain pure substances. So we don't want any impurities, whether solid or liquid, present in our pure liquid, which is distilled water. And that is the purpose of the function of the thermometer. Any other temperature other than the constant boiling point of the liquid means the distillate is impure. Let's look at our condenser. The condenser shows cool water in at the bottom and water out at the top. What is the purpose for the arrangement? If cold water enters, that is, if cold water enters at the bottom of the condenser, this means the flow of water will be opposite to the flow of the water vapor or steam. So if the steam is flowing downwards and the cold water is flowing upwards, the opposite direction in which both substances are proceeding, this would lead to an increased cooling of the water vapor, meaning that the rate of condensation will be faster, such that water vapor which enters into the condenser, all or most, if not all of it, would cool and condense and be collected in the receiver. And this is our setup for simple distillation, as well as an explanation of the arrangement of the apparatus. You should as well know how to draw a simple line diagram of the condenser attached to the distillation flask fitted with the thermometer.